Welcome to the learning activity or activation activity as we've been calling them in previous units for the last unit in pre-cal. So woohoo, you're almost done. The key concepts that we're focusing on in this activation energy is just reviewing fractions. So we've been seeing them all semester, but just to really hammer out all those kind of little nuances, all the little rules for adding, subtracting, multiplying, and dividing. So it kind of talks you through them I'll do a couple examples. I'm not going to do every example because, again, this is a learning activity and activation activity. This is looking for you to use knowledge that you already have. So I'm not going to go as in depth here. So our key concepts to remember about fractions, that's what we're going to start, because our whole unit is about rational expressions, and that means that we're dealing with expressions and equations that not only are fractions, but fractions with variables in the denominator. So we really got to be comfortable here. So in a fraction, the top is called the numerator. The bottom is called the denominator. Okay, so that's what we're looking for in terms of filling in these blanks. Pause the video right now and see if you can figure out the words on your own. If you can't, that's okay. When you restart this video, I will have the answers pop up. So pause it right now, and then we'll have them show up again in a second. Give it a shot on your own though. Okay, so here are the correct answers to fill in the blank. The key thing I want to point out is we are looking at mixed fractions here. That's the example. So 1 3/4, the improper fraction. So when the numerator is greater than the denominator. In terms of wrapping your head around what a value actually is and maybe how big it is, sometimes it's easier to think about it in a mixed fraction form, but improper fractions are actually easier to manipulate when it comes to doing different mathematical operations. So we are going to be working more with improper fractions. If you get an improper fraction as an answer, you are more than welcome to leave it as that. Just make sure it's reduced if it has a common factor in both the numerator and denominator. So adding and subtracting, how we do that is we must have a common denominator. Okay, so right now we've got 1/6 and 2/3. So how we see that here is we've got 1/6 in the green, 2/3 in the purple. Okay, how do we add them together? Well, we can either take all of these pieces and fill them in up here instead, or we can subdivide this last one and add in that last sixth. Either way, I would probably subdivide into smaller pieces. So each third is actually worth 2/6. And we can visually see that. This is 2/6 and this is 1/3. So I can break it down. And so when I see 2/3, how I'm now going to think about it is I've got 1/6 and 4/6. So that's my equivalent fraction. So I can multiply it to get there. Multiply this by 2 and times 2 so that I get the same, my whole is represented by the same number of pieces. Okay, if I was then going to add these together, well, now I've got 1/6, and if I filled it in, 2, 3, 4, 5. And so in total, I have 5, 6. So then we add the numerator. The same principle applies when you're subtracting. You always just want a common denominator. So what we can do here is we are going to, actually, you can try those on your own. So pause the video now, give them a shot, make sure we're good to go on the whole adding and subtracting fractions thing. Okay, so example 2, we've got 7/12. Example 3, 1/2. If you're not sure about that and you need some more confirmation on how to manipulate fractions, please touch base with me. Okay, multiplying fractions, you can think of it as an array. So vertically, we can represent it if this whole side represents 1. If we divide it into 8 pieces and shade in 3, that's 3/8. Working the opposite direction, or vertically instead of horizontally, the whole thing represents 1. So if we divide it into 3 pieces and fill in 2, then now I've got 2/3 and 3/8, and where they cross is my solution. So really it's going to be 6 out of 1, 2, 3, 4, 5, 6, 7, 8 times 3 is 24. Okay, so my solution should be 6 over 24. Now you may already spot that there's a relationship here between the numerators multiplying together, the denominators multiply together. It's also highlighted in that image here. Okay, but you can think of it as an array, so if it helps to draw it out, you are more than welcome to do that at any point. So you want to pause the video, give these 2 questions a shot. Remember, numerator times numerator, denominator times denominator. Now remember what I said, and I totally didn't do it here. I was too caught up in just making sure we understood this whole array method. We can reduce this. 6 goes evenly into 24, and so we get 1/4 instead. Okay, I left example 6 blank because I wanted to just point out that you can look across as well as within a fraction to look to reduce, because we're multiplying and dividing, and so those are opposite operations, and their order of operations kind of is flexible within that. That's only for multiplying and dividing, adding and subtracting, not so much. Okay, so what happens here is that 2 and 4 actually have a common factor of 2. So I could reduce this to 1/2 going diagonally. Now if I multiply this, I get 3/10. If I had done the question originally, 3 times 2 and then 4 times 5, I would have had 6/20, which I would have then been able to reduce to 3/10. So by reducing before I even do my arithmetic, that allows me to get a reduced fraction quicker. So it's up to you, whatever you want to do, but that's your call. Okay, so dividing fractions is a little bit interesting. The idea is that it's saying how many, if we talked about division in terms of words, it's saying how many halves go into a whole. That's this particular question. So visually, we can see this very quickly, that 2 halves make a whole. When we look at 2/5 going into 2, we could draw that out as well. So we've got 2 wholes, or representing them as 2 separate wholes, and then we can subdivide that into 5 pieces each. So that's, and then we want to see 2/5, so we're grouping them in 2 instead of just 1/5, because 1/5 goes into 2 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 2/5 goes in 1, 2, 3, 4, 5 times, and so we end up with 5 as my answer. Example 9 here says, okay, well, we've got 3/4. 1, 2, 3, 4. And that's how it's originally divided. If I divide it by 2, what am I actually dealing with? And the correct answer is I'm dealing with just one set of those. And so I'm dealing with 3, but now instead of dealing with just 3/4, I have 8 whole pieces here. So it's 3/8. So that's another way of thinking about it. Now, when we do division with fractions and fractions, it becomes a little bit more complicated. You can still represent it using either of those methods above, but how I like to usually tackle it is using the reciprocal and multiplying. So remember that 4/5, and you may have seen this before, divided by 2/3 is the equivalent to 4/5 multiplied by 3/2 by the reciprocal. Okay, which means from here I multiply like normal, so 4 times 3 is 12, 5 times 2 is 10. Alternately again, I could have looked at this and said, okay, well, 2 goes into 4 twice, so I've got 2 times 3 is 6, 5 times 1 is 5, and that is equivalent to my other answer. So it just gets me to my reduced form a little quicker. So there's a bunch of questions for you to practice. Adding, subtracting, multiplying, dividing, all fractions, all without common denominators, I think. Yep. So you're going to be looking for ways to manipulate them. You don't need a common denominator for multiplying and dividing, just adding and subtracting though. So give these a shot, and then we'll start our first lesson.